Hello everybody, welcome back to another Python video. This is the fifth video in our series, or excuse me, the sixth video in our series on image processing using PIL. And in this video, you can already see we're using an image that's different from what we've been using in our previous videos. So to get started, all I've done is I have my imports, and here I have this Barbie grid image. So this is an image that I created, and that's going to become relevant in a minute. And here's what it looks like. I've also defined ARR to be the NumPy array version of this image. So the first question we might ask is, well, how many unique colors are in this image? Now, just looking at it, it looks like 3 unique colors, right? Like we have this light pink, dark pink, and then we have this white color here. So just because it looks like there's 3 images, when images get saved and compressed, usually what happens is pixels get distorted just a bit. So instead of having exactly one color, it'll be a bunch of very close colors. So I specifically designed this image so that exactly 3 colors show up. Almost, I would never expect this to happen otherwise. And that also explains why, if you zoom in on this image, there's a lot of what's called aliasing. So notice how jagged these letters look. And it's because if I want it to be more smooth, what ends up happening is it does a blurring effect where instead of having it be just white pixels, it kind of slightly perturbs the points so that it blends in more, very loosely speaking. So if you're wondering why does it look more jagged, I can certainly make it look better, but we're not going to get exactly 3 colors that way. So, okay, we know there should be exactly 3 colors. Let's try something like, what if I say, well, maybe even before I'm going to say, well, what's ARR of shape? So this is a 1000 by 1000 by 3 NumPy array. So 1000 pixels by 1000 pixels. This is already a lot larger than our previous image. And remember the 3 here, that's holding our RGB values. Now I could say, okay, let's look at ARR. Let's look at the 0th row. And we can notice we have, so it looks like there's this one color, here's another color, and somewhere in there we should have the white color, so in these rows here. So what's wrong with trying something like np.unique, and if I try ARR, so what happens here is it's actually flattening ARR, so it's looking at all of the numbers in ARR and plucking out just the unique ones. But I want to store the RGB triples with the colors. So I don't want to say, okay, what are all of the integers that show up? I want to say, what are the RGB triples? So what I'm going to do is I'm going to say b equals ARR.reshape. And what I'm going to do is say -1, 3. So meaning put whatever you need here to make this 3 work. And if we look at B, we can see the rows here are RGB values. So this is exactly what we want. Now, if I try something like np.unique on B, it's still not going to give quite what I want. So notice it still flattens B and just returns kind of the unique integers that show up in B. So lucky for us, if I do np.unique of B, so this has an axis argument. So notice if I run it just like this is still looking at all of the integers in B and just saying, okay, what are the unique values that show up? Instead, I can say axis equals 0. And let's see what this returns. So we can see here, this returns 3 different RGB values. So maybe I'll call this, I don't know, C. And if I look at C.shape, we can see it's 3, 3. So this 3 here is telling us how many kind of the RGB values, but this 3 is telling us there's exactly 3 unique colors. So if we take a look at C, here are the 3 colors that show up. Awesome, so that was the first question I wanted to answer, how many unique colors show up. Again, it took quite a bit of work to get that to work out exactly to 3 colors. Like I said, most of the time when you generate an image and download it, there's going to be some type of compression or some type of anti-aliasing that kind of changes the pixel colors ever so slightly. So that's the first question. Second question we can ask is, well, where do the colors change? So what I mean by that is, let's look at image again. So let's say I'm just looking at this first row and I'm interested in seeing, okay, where does it go from the light pink to the dark pink? Light pink to dark pink. So what I'm going to do is I'm going to take the first row of ARR and we can see, okay, there it is. What's the shape? and we can see here it's 1000, 3. So remember, we have a 1000 by 1000 pixel grid, and then the RGB value, so that's where the 3 comes from. And now one thing I can do is I can say ARR of 0. Where is this equal to? So this 249, this is the top left corner. So this is that lighter pink color. So I can say, where is it equal to this color? And we can see here it's saying true, 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 and so on. So what I'd really hope is that, and then maybe let me even start with the darker pink color, because I want to show you something a little bit different, hopefully. Maybe not. So I was hoping that we'd get a mix of true and falses, but actually what happens is because the two numbers don't share any values, so these are all going to be false, but what I really want ultimately is I want it to return false for this entire row, false for this entire row. I'm going to go back to the light pink really quick. Or no, let's keep it with the dark pink. Basically, we'll keep track of where the dark pink starts. So this is the dark pink. And what I want to do is I want to say, okay, instead of having it return false, 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 for instance, I just want to have false returned for the whole row. So the way that we can do that is we can say dot all. And here's an axis argument. I want to plug in like this. So this would be axis equals 1. And let's see, maybe I'll call this Boolean mask. So BM for Boolean mask. And I can say what's bm.shape. And we can see here it's just a length 1000 one-dimensional NumPy array. So this is returning for every row of ARR, or really every column because we're looking at the first row. It's returning true if all of those values are in that pixel are equal to this color here, false otherwise. Great. So now what we can do is to get the indices is we can just say np.non-zero Boolean mask. And remember what this does is it returns a tuple. So to get the first element, I'm going to say 0. And then, okay, this is giving me the array. That's looking good. And what's happening here is it's saying, okay, at index 100, that's where it starts being that dark pink. So it goes 100, blah, 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 blah. And because I coded this image, I know that at 200, it should switch. There's 199. So what if I wanted to get exactly, so what is happening here is it's telling me it's dark pink for this A1 box. So this entire thing, and then A3, A5. What if I just wanted where it switches? So right at this point where it goes from this A0 to A1. And the way I can do that is as follows. So I'm just going to call this INDS for indices. All right, now I can say X for X in indices. Now think about it. If, let's take a look at indices again. So I want to keep the point if the number right before it, so 99 is not included in indices. So that means I switch colors. Notice when we get to 199, so 200, not included. So if the number right before it is not in the indices. So if x minus 1 not in indices. So here we can say at 100, 300, 500, 700, and 900. So going back to the picture, there's 100, 300, which was the next one. Then we would have 500, 700, 900. All right, I think this is a good place to end this video. Thank you for watching.